All right, we're gonna go out looking for local extrema. Um, that's not as interesting as it sounds. Extrema just means the maxima and minima of a function, and maxima is the plural of maximum. So the maximum points of a function or the minimum points of a function. Minima is plural of minimum, so you can think of it as minimums. The more I say that, the stranger it sounds. Extrema, the maxima and minima of a function. So yeah, okay, so local extrema are the extrema of a function within a certain domain. So there's, let's contrast them with global extrema. The global extrema are the extremes for the whole function itself. The highest point or the highest points, if it has 2 points that are the same height that are maxima, or the lowest point or points of the whole function. Local extrema are the extrema only within a certain restricted domain. So, and I'll show you concretely what that would mean. So, easiest way to find um, the or n a very easy way to find the local extrema of a function is to graph it because visually you can see where they are. So for example, we've got this function here, and we can look at a certain restricted domain. We could say, let's kind of just ignore everything outside of these lines and look at the interval from, let's make it whole numbers, from -5 to -1. Over that interval, the maximum is this point right here. The highest value within that restricted domain is that point right there. So it's roughly where x is equal to -3.75, let's say. With your graphing utility, you could actually figure out exactly where that is. Um, or yeah, so but by visualizing it, you get a good sense of what you're looking for. So there would be the maximum of this interval. You could extend the interval to let's say the interval were from -5 to +2. Um, well, over that specific interval, actually, y equals 0 is the maximum because that point, is higher than that point there. But let's say you moved the interval. Sorry, you're just looking at the interval from -5 to 1. The maximum would be this point here. The minimum, the local minimum, well, actually it's like right there, where the thing kind of bottoms out, right? So minimum, maximum, not of the entire function, just for this restricted domain. Because look, I mean, there's points down here that are much lower than this point. In fact, this graph in particular goes towards negative infinity and towards positive infinity. So it doesn't actually have any global extrema. There is no maximum point. It just goes on forever to positive infinity. It goes on forever to negative infinity. But if I look within a certain restricted domain, there's a local maximum and a local minimum. Um, so let's look at another example. Here's a parabola. Now, if I were to say what's the global maximum of this parabola, because it opens upward, there is no maximum. Any maximum that you think there is, there's something higher than that because it goes on to positive infinity, right? So there is no maximum, and in fact, um, so you could just come up with some kind of weird interval and say, well, um, y equals 6 is, that's the highest value at the interval, but that's not that interesting. Um, what is interesting is that there is a global minimum. There's no global maximum, but there is a global minimum, and that's at this point where y is -2. So that's interesting. Um, And even if you were to look at this restricted domain, the local minimum would be that same thing. Whereas if you had a domain over here, the local minimum would be uh, over there. But really, kind of the most interesting points are where the direction of the graph would change. You know, where there's like the bottom of a parabola or bottom of a curve or something like that. So that's looking for a local extrema. Um, it they're like global extrema, except you're not looking at the entire function. You're looking at a little section of the function. Um, and yeah. All right.